In this video, we're going to look at division questions that have remainders in the answers. So the first part of breaking up the number is very similar to the steps shown in the division step 2 video. So here we want to ask ourselves how many 6's in 49, or how many times can 6 go into 49? And it's really important for students to recognize that 49 is not a multiple of 6. And the next step after that is for students to be able to recognize that the multiple that is closest to 6 is 48. And if we look for the other part of that number, so 48 plus 1 is equal to 49. At this point, we're going to go divide each one of our parts by 6. So how many 6's in 48? The answer is 8. And the remainder, in this case, 1 divided by 6, it's important that students make the connection that the division can also be represented as a fraction. So in this case, we are going to represent our answer as 8 and 1/6. In the next example, we're going to work with remainders as well, but we're going to go draw into what students have done before when working with partitioning larger numbers. So in this case, similar to the division step 2, how many 7's in 350, which is 50, and the other part of the number, the difference between 350 and 355 is 5, and when I divide that by 7, I get the fraction representation 5/7. So my answer for the second question is 50 and 5/7. In the third example, again, I start by asking myself how many 8's in 65. And in this case, again, it's important that students recognize that 65 is not a multiple of 8, but that 64, or in this case 640, is the closest multiple of 8 to 65. And then my second part of my number, so the difference between 640 and 650 is 10. But in this case here, I see that 10 is also not a multiple of 8. So what I'm going to do is break up this number again as 8 and 2. And then I can go divide each part by 8. So 640 divided by 8. Oops. Is 80. 8 divided by 8 is 1, and 2 divided by 8 can be represented by the fraction 2/8. So now if I find the sum of these parts, I get 81 and 2/8. Now students can, if they see the relationship between 2/8 and 1/4, either rewrite their number as 81 and 1/4, or could even write it as a decimal as 81 and 25/100. But any of these answers in any of those representations is acceptable at this point. Now what's important when you're working on these practice questions is to really recognize that, especially in cases such as this, 8 times what is 65, it's very, very important that student be able to recognize efficiently that 65 isn't a multiple of 8. And also, it's important that they can recognize that 64 is the closest multiple of 8 to 65. Now, it's not really a time thing. When we say that they have to recognize this efficiently, I'm more referring to the type of strategy they use. So are they guessing and checking? Are they counting on their fingers? Are they doing a lot of addition? Those aren't the strategies that are the most efficient to solve these questions. So if there are some issues with that. The most important suggestion that I could make would be to go back and work on some practice questions from Division Step 2 or Division Step 1. As usual, I've left some practice questions in my Dropbox if you click the materials button just next to the video.